So children, this is your 12th physics, chapter 3, current electricity. Today we are going to cover the topic series and parallel combination of cells and Kirchhoff's law, right? So let's start with it. Cells. So cells are used to provide the voltage, right? Now, cells are used in series as well as they are used in parallel, and there are many applications in which cells are used and in combination. A single cell, children, it provides very weak current. So in order to get higher current in a circuit, we often use combination of cells, that is two or more than two cells. And as we have done in class 10, the combination of cells, that is when more than one cells are connected together, it forms battery. Now, the battery cells are used in torch, they are used in automobiles, they are used in transistor sets, etc. Right? So, cell can be used in series, they can be used in parallel, or they can be used in mixed way. Right? So, let's start with the cells in series combination. So, when are the cells said to be connected in series? So, as you can see on your screen, children, that the negative of cell number 1 is connected to positive of cell number 2. The negative of cell number 2 is connected to the positive of cell number 3, and so on. So, when the negative terminal of one cell is connected to the positive terminal of another cell, and so on, then the cells are said to be connected in series. Then the cells are said to be connected in series, right? Now here, children, we are having n cells, right? N cells hai, and we are connecting them all in series. The EMF, we have done electromotive force, right? Electromotive force is the maximum potential difference between the terminals of a cell when no current is drawn from the circuit, right, children? So the EMF of a single cell is E. Similarly, all cells are having same EMF. So we have connected n cells, each of EMF E. So the total EMF of the cells in series will be E plus E plus E plus N times E. So the children, the total EMF will become NE. So this is your total EMF, that is NE. Now the internal resistance. Here the cells which we have connected, each of them is having an internal resistance of R, right? And as each cell is having the same internal resistance R, and all these internal resistance R, they are connected in series. So we can apply the formula for resistance in series, that is simple addition, that is R plus R plus R plus R n times. So the total internal resistance is NR. Now let's talk about the total resistance. Total resistance is the total internal resistance and the external resistance which is connected in the circuit. This is also resistance. This is the external resistance which we have connected. So the total resistance will be the total internal resistance, that is NR, plus capital R. Why plus? Because beta capital R resistance is also in series. Yes. So we have added them. Now from Ohm's law, we know that V equals to IR. And if we make I subject of formula, I equals to V by R, where V is the total voltage and R is the total resistance. So your total voltage, that is your total EMF. V is how much? Ne. So यहाँ पे बेटा Ne आ गया. And R is the total resistance. So we know the total resistance, just now we calculated, and the total resistance is Nr plus R. So it is Ne upon Nr plus R. So this is the current that will be flowing in this combination. Now, here we are going to suppose two things. There are two cases. If the internal resistance of the cell, that is Nr is the total internal resistance of the cell. If that is very large, suppose that value is 1000, and the resistor which you have connected in the circuit, capital R, suppose that is 1 ohm, and this is 1000 ohm. So 1 ohm is very less than 1000 ohm, right? So in this equation, under this condition, capital R can be neglected. We can remove capital R because 1000 plus 1 is 1001, which is near about 1000 only, right beta? So if the value of R is very small, then in this equation R can be neglected. So we are removing R, and our equation becomes I equals to Ne by Nr. N cancel, so I equals to E by R. This is the current that will flow in the series combination of cell when the external resistance R, capital R, is very less than the total internal resistance. Now let's take the other condition, other way out. That is, अगर हम बोले बेटा that NR value is very small as compared to the external resistor R. So under that condition, what we will do, children? Under that condition, if capital R is very greater than NR, then we will neglect NR. So we will remove NR from this, and our current equation will become Ne by R. So this is the amount of current, right children? Now just see from both the equations under which situation the value of the current is maximum. In which case the current flowing is maximum. Yes, in the second case, because here it is E by R and here it is N times E by R, where N was what? N was the number of cells. Means if you are connecting 100 cells in series, then the current that is flowing will become 100 times. Right children? So this was the case when your internal resistance value was very less, means it was negligible, right? So what is the conclusion of this? It concludes that when the internal resistance is very less, it's negligible as compared to the external resistance, then the cells will get the maximum current, that is Ne by R. This was cells in series combination. Now let's see cells in parallel combination. So here children, again n cells are connected in parallel, right? Now when do we say that the cells are connected in parallel? When all the positive terminals of the cell, they are connected at the common point, at the same point. And similarly, all the negative terminals of the cell, they are connected at another common point, right? Means all your cells, positive terminals are connected at a point, at a common point, and all the negative terminals of the cell are connected at another common point. Then the cells are said to be connected in parallel. Now, these cells, they are having, each of them is having the EMF E. Here you can see its EMF is E. And internal resistance of each cell is R. Means they are having same EMF. We have connected those cells whose value of EMF and value of internal resistance is same. So same cells we have connected. There are N cells. Now, the total EMF when they are connected in parallel. So we have done, children, that when they are connected in parallel, the total EMF will be same. In parallel combination, the EMF will be same. So here the total EMF will be E. right? Series में क्या किया था? In series we added them, that is E plus E plus E n times, that is NE. But in parallel, the EMF across each branch is equal, it's same, that is E. Now let's talk about the total internal resistance. Now here you can see all our small r's, they are connected in parallel. So we know the formula for parallel, that is 1 by r parallel equals to 1 by r plus 1 by r n times 1 by r, right? If you take the LCM, LCM is r, so LCM is there, and in the numerator you will have 1 plus 1 plus dot 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 plus 1. कितने times? n times. तो ऊपर क्या आ जाएगा बेटा? n. So children, you will have n r n by r. This is 1 upon r parallel. And if we do the reciprocal, it would be r by n. So this is the total internal resistance, that is r by n. Now let's talk about the total resistance. Total resistance we know, that is internal plus external. So external is this, right children? And external is connected in series, one after the another. So we are simply adding them, and after simply adding them we get r by n plus capital R. Now similarly, if we calculate current I is V by R. V is how much? E, and total R is r by n plus R. Now here also we are going to consider two cases. First case, we will make R very very less. If capital R, the external resistor which we have connected, is very less then r by n, then we can neglect capital R. And if we neglect capital R, our equation of I will become I equals to NE upon small r, because it would be like this beta, I equals to E upon r by n. This n will go up in the numerator and it will be I equals to NE by r, right children? Okay. Second case is what we will do. Second case we will make R very big. Means your R by N is very small. It's negligible. So we'll negligible. We will remove that. And if we remove R by N, our current equation will become E by R. Our current equation becomes E by R. Now children, let's see under which condition the current is maximum. Yes, the current is maximum in this condition because here the current is n times, right? So this is the condition, that is when your external resistor which you have connected in the circuit is negligible as compared to the internal resistance, total internal resistance Rn, then the current that will be flowing in the circuit will be maximum. So children, this was about your series and parallel combination. That is, the conclusion is when the external resistance is very less under this condition, then the cells are in parallel will get maximum current, right? This is what we did. Okay, now we are going to start with Kirchhoff's law. So, children, this is the condition. In the first condition, here we can find out the total resistance. हम total resistance find कर सकते हैं यहाँ पे parallel लगा के, है ना? Parallel series वाला formula लगा के हम find कर सकते हैं, right? We can calculate the value of current. If we know the value of E, we can calculate the current also from Ohm's law. And if we want to find out children the potential difference across AB के across अगर हमें potential difference find करना है तो हमारे पास R है, we are having current, we can find potential difference using Ohm's law, no problem in that, right? But children, if the circuit is complex, if it is very complicated, as you can see in the second case, here we will see here one cell is connected, here another cell is connected, here also a cell is connected, and there are lot many resistors which are connected. Yes, so children, this is your very complex circuit. This you cannot solve with the help of Ohm's law, right? So you need to learn, you need to have an idea for Kirchhoff's law under this condition. Let's start with the Kirchhoff's law. So before starting with the Kirchhoff's law, we should be knowing few terms. So Kirchhoff's law, what does it do? It helps us to determine the current in each branch of a complex circuit. So हर एक ब्रांच में कितना करंट फ्लो हो रहा है वो किर्चॉफ्स लॉ की हेल्प से we can calculate. Now what is branch? That all I am telling you, right? Suppose we are having the circuit that is given to us is this, right? Now let's start with the first point, that is junction, or also it is also known as node. So let's see what is junction or what is node. So a junction is a point where three or more than three conductors are connected. So children, if you see this point E, at this point, this 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 element is connected, and from here this wire is connected. So at point E, children, we can see only two connections. So E is not a junction. But children, at point A and at point E, here you can see that three elements are connected. At point B, this is connected, from here this is connected, and this is connected. Similarly, at point A, from here R is connected, from here R is connected, from here R is connected, and so three conductors are connected at point A as well as at point B. And at the rest places, that is at E, F, C and D, only two conductors are connected. So they are not junction. Right, children? So what is a junction? A junction is a point where three or more than three conductors are joined. And in our case, A and B are your two junctions, or they are two node, right? Next, the branch. So branch is that path, it is that rasta which connects from one junction to another junction. So here we are having two junctions, A and B are two junctions. So A और B को connect करते हुए जो current का path है, so here one we are having direct, that is from A to B also the current is going to flow. So AB is one branch. Yes, AB is one branch, correct, right? But current is going to flow in this direction also, on this path also, है ना? From A to E, E to F, F to B and B to A, right? So this is also, children, one branch, AEFB. So AEFB is your second branch, right, children? Similarly, we are having one more path, one more rasta, which is going to connect one junction to another, and that is ADCB. This is also one path which is connecting junction A to junction B. So that is your branch, right, children? This is your branch. And the last term over here is loop. Now, as we know, the complete loop. So जहाँ से हम start करेंगे, we will end at the same point. So for loop, let us start. And that is your, suppose we start from point A, right? A से start किया, AEFBA. This is one loop. Similarly, you are having one more loop on the other side, that is ADCBD. So these are the two loops which are also known as mesh, right, children? So junction, branch and loop. Junction where more than three or more than three conductors are connected. Branch is that path of current which joins one junction to another junction. And loop is the closed path in electric circuit. किसी भी circuit में the closed path on which the current is going to flow is your loop. Okay. Next is, let's talk about Kirchhoff's law. There are two laws in this. First is KCL. KCL is Kirchhoff's current law, which is also known as junction rule. And second is KVL, which is Kirchhoff's voltage law, which is also known as loop law, which is also known as loop law. Right, children? So let's start with the junction rule first. Junction. Now we know the word junction. Junction is a point at which two sorry, at which three conductors, three or more than three are connected, right? So what is the law? The law says that, children, the sum of current at a junction is zero, means the total current, that is sigma I equals to 0. For example, if we consider over here I1 current is coming, here I2 current is coming, then and here I3 current is moving. So these are your directions. So here can you say that I1 plus I2, can you say here that I1 plus I2 equals to I3? Because I1 or I2 मिला के ही तो I3 बन रहा है, they are moving together, right? So if I add them all, that is I1 plus I2 and your I3, if I3 goes that side, it will become minus I3 equals to 0. Yes, I3, if it goes on the left hand side, it will become minus and equal to 0. So here you saw that when you are adding the current at a junction, they are all equal to 0. It means that, children, the total current that is entering a junction, so in this junction, children, the total current that is entering is how much? I1 and I2. That is equal to the total current that is leaving the junction. Leaving is how much? I3. I3 जा रहा है और उस junction में at this point कौन सा current आ रहा है? I1 and I2. So I1 and I2 they are equal to I3. So this is your Kirchhoff's current law, that the total current at junction is 0. That is, the current entering a junction is equal to the current leaving the junction. Now be attentive, it is very easy, not a big deal, just be attentive in this. As you can see here, children, 40 ampere, as you can see here, 40 ampere of current is coming, and this is the point junction. Now from 40, 15 is going upwards, right children? From 40, 15 is going upwards. So what is the amount of current that is coming in this direction? So it is but obvious, 40 minus 15, and that is equal to 25 ampere. So here children, how much current is coming? 25 ampere. Right children? Here 25 ampere current is coming. Now here you can see 20 ampere current is coming, and from 20, 10 has gone this side. So how much current is left? That is 20 minus 10. So 10 ampere current is coming from this side, right? So what will be I over here? That will be the addition of the two. So the total current, that is small I, is 25 plus 10 ampere, and that is equals to 35 ampere. I hope this is clear. Right children? Next here you can see this is the junction point, right? From here 20 ampere is coming, from here 10 ampere current is coming, right? And here children, as you can see, 15 ampere current is moving down. So how much current is in this coming on this side? How much current is coming in this side? So the total current is how much? 20 plus 10, 30. From 30, 15 has gone in this direction. So what is left? 30 minus 15, मतलब यहाँ पे 15 ampere current is going to flow. Yes, 15 is flowing, fine. यहाँ से 20 आ रहा है बेटा, right? So अब ये combine होके इधर move करेंगे बेटा. So 15 plus 20 is how much? 35. तो यहाँ पे कितना आया? 35. 35 में से 5 has gone in this direction. So how much is left? So it's 35 minus 5, and that is equals to 10 ampere. 35 minus 5, that is equals to 30 ampere. Right children? So these were your two examples to explain you the Kirchhoff's current law. So this is all for today. We'll end our class here.